Here we introduce a method for solving quadratic equations. What is a quadratic equation? A quadratic equation is anything of the form ax squared plus bx plus c equals 0. That is technically a quadratic equation. The only stipulation we have is that a does not equal 0. Not to be confused with the quadratic formula, which is a formula used to solve quadratic equations. So what we have here in our example is a quadratic equation. We have x squared plus 6x plus 8 equals 0. And there's a method for solving these called completing the square. It involves several steps, and here they are. It really looks quite complicated when you write out all the steps. It's easier in practice, I would argue. But here we go, completing the square to solve x squared. Note that here we're assuming that a equals 1. We'll have to do something special in the case that a does not equal 1. Okay, so here are the steps, and let's just follow the steps along with this example. X squared plus 6x plus 8 equals 0. Okay, get c to the right side of the equal sign. Okay, so here's what I mean by c. This is the plus 8, so we'll subtract 8 off from both sides. Right, that leaves us with x squared plus 6x. And then I'm going to leave some space equals negative 8. Okay, so you want to leave some space there. The next step says to take the b term and divide it by 2. So remember, the b term is this middle term here. I've bolded it. It's the one that goes with the x. So here's our b term. This is what I mean by b. You take that, you divide it by 2. Okay, well that gives us 3. Square that result. Okay, 3 squared equals 9. Okay, square that result. Add that result to both sides. Okay, so now I'm going to add this 9. So we have plus 9 and plus 9. Okay, so let's rewrite what we have here. X squared plus 6x plus 9 equals 1. The next step here, step 5, says write the left side as a perfect square. When you use this method, the left side will have made a perfect square trinomial, such as this, which always can be written as a plus b quantity squared, or a minus b quantity squared. So this equation is of the form a squared plus 2ab plus b squared equals 1. Okay, well this makes a perfect square trinomial. So on the left we have something squared equals 1. That thing that goes inside the parentheses, x plus 3. I'm using this equation over here to get that, but really, in practice, you essentially take the square root of your first term here, and then the square root of the last term. So the square root of the first term goes in the first slot, the square root of the last term goes in the second slot. That gives us x plus 3 quantity squared equals 1. Now for step 6, we use the square root property to solve it out. So we take the square root of both sides. Don't forget to add on the plus or minus. That's the square root property. And that gives us x plus 3 equals plus or minus rad 1. But rad 1 is just 1. Solving for x now, x equals minus 3 plus or minus 1. Now you wouldn't want to leave your answer like this. You only leave it at this stage if you can't simplify it any further. Like if this was minus 3 plus or minus rad 5. But this we can actually work with, right? We have x equals minus 3 plus 1, and we have x equals minus 3 minus 1. Okay, so that gives us negative 2. That's one of our answers, and then it gives us negative 4. That's another answer. So completing the square may seem a little clunky, but it's actually a very powerful method that can solve any quadratic equation, right? Maybe you're looking at these answers and saying, I think I could have gotten that by just factoring, and sure enough you could have, right? Don't forget our factoring method. We could have factored this equation. That would have given us x plus 4, x plus 2 equals 0, and then very quickly we could have gotten x equals minus 2 minus 4. Well, that's demoralizing, right? Why do all this work if we could have done it in essentially 2 steps? The reason is that completing the square will get us the solution to any quadratic equation, not just ones that can be solved by factoring. So if this quadratic would have had square root answers, we couldn't have factored it to get those answers. Now, completing the square is very useful for more than just solving quadratic equations. We'll use this method extensively when we go to plot circles, and then again when we get to ellipses, hyperbolas, parabolas, right? So it's a very frequently used method. We get it down right now, but you use it again and again throughout different areas of algebra. So sometimes people ask, hey, if I know a different method to solve quadratic equations, can I just use that instead of learning completing the square? And I always say no, because we need completing the square later for other applications. So get it down now, it's going to pay off down the road.